an important tool in power generation. In a steam turbine, heat generated from the burning of fossil fuels is used to boil water, which produces high pressured steam. This high pressured steam then expands into turbine blades, which rotates them and produces mechanical energy. This mechanical energy is then converted to electrical energy through a generator. In this video, we will be explaining the fundamental principles of the first and second law of thermodynamics in this application, as well as the thermodynamics analysis in steam turbines.
Assalamualaikum and good morning. My name is Miki Kitai. My metric number is 218436, and today I will explain the first law of thermodynamics and how it applies to the operation of a steam turbine. So, the first law of thermodynamics states that it is based on the principle of energy conservation. Energy cannot be created or destroyed, but it can be transferred or converted from one form to another. In a thermodynamics system, this law is commonly expressed as Q equals delta U plus W. Q is the heat added to the system. Delta U is the change in internal energy, and W is the work done by the system. Put it simply, the heat supplied to a system either increases the internal energy of a system or is converted into useful work. Now, let's look at how this law applies to a steam turbine. A steam turbine is a device that converts thermal energy from high pressure, high temperature steam into mechanical work. Steam produced in the boiler enters the turbine and expands as it passes over the turbine blades. During expansion, steam loses internal energy and is converted into a shaft work that rotates the turbine. Applying the first law of thermodynamics to a steam turbine operating under steady flow, the energy balance can be simplified to W turbine equals H in minus H out. This equation implies that the work output of the turbine is equal to the decrease in the specific enthalpy of the steam as it flows through the turbine. So, the thermal energy carried by the steam is transformed into mechanical energy. In practical power plants, steam turbines are key components of the Rankine cycle. Heat is added into the boiler, work is produced in the turbine, and energy conservation is maintained throughout the cycle, according to the first law. In conclusion, the first law of thermodynamics explains how a steam turbine operates by conserving energy while converting heat energy from steam into useful mechanical work. This fundamental law is essential for analyzing and designing efficient power generation systems. Thank you.
Assalamualaikum, my name is Arif Nuruddin Mastuddin, metric ID 231785. So, I will be explaining about the second law of thermodynamics in steam turbine application. So, basically, steam turbine uses thermal energy to convert into mechanical work. In second law of thermodynamics, stated that not all energy can be converted into mechanical work. So, there will be a picture of the turbine, steam turbine here. So ideally, you want an isentropic expansion where the energy is perfectly converted into the mechanical work without any heat loss and energy loss. The entropy is remain constant. But in real life turbine, there is always going to be an energy loss where the entropy will increase due to the friction between the steam and the blades, the turbulence in high-speed flows, and also some internal irreversibilities such as leaks, heat loss, and also mixing of energies. So, due to the friction, turbulence, and also the irreversibilities, they will cause the energy to spread randomly in the turbine, which will cause the entropy to increase. Which means that less energy will be available for work, converted into work. Here next we have the temperature times entropy diagram, where you can see from point 1, which is the pump, from the cycle, which is pump, going into the second point, which is the boiler, and where the temperature and pressure will be increased into 2 prime and also to the peak, which at the 3.3, where it will be the steam exiting from the boiler that will entering the turbine. So in the turbine, as you can see from the diagram, where it will decrease, going downwards, the turbine output, and to steam leaving the turbine until reach point 4, where the turbine heat loss or energy loss will occur for entering the condenser. So basically, in second law of thermodynamics, this also explains why condenser is necessary in the cycle, because not all heat from the steam can be converted into work. So the remaining heat, excessive heat that has been rejected, will be going through the condenser, which will allowing the entropy to be removed and continuing the cycle, where it will go back into the pump and boiler and up to again, where the cycle continues. So this means to say that the actual work is less than theoretical work, and the isentropic efficiency will not always going to be 100%, and the entropy that generates is proof, because second law of thermodynamics limits the turbine efficiency. So not all heat energy can be converted into mechanical work. That's all. Thank you.
From thermodynamics analysis, it is found that steam turbines are represented by the Rankine cycle. The Rankine cycle describes the process by which certain heat engines harness thermal energy in order to generate electricity. In an ideal Rankine cycle, the steam turbine would be isentropic, which means zero entropy is generated, and it will be able to maximize the work output. But in real life, the steam turbine is not isentropic, which means processes are non-reversible, and entropy is increased by the processes. This increases the power required by the steam engine and decreases the power generated by it. Therefore, the efficiency of the steam turbine is limited. In conclusion, from the research done from our video, we have found that steam turbines, and by extension a lot of man-made systems, are not 100% efficient. And although because of the second law of thermodynamics, and even though multiple research and methods have been done to increase the efficiency of our systems, the fundamental principle of thermodynamics cannot be broken. That is all from us. Thank you.